So the topic of today's presentation, acceleration and packet processing, are we at a plateau? So at Dell'Oro Group, I am the analyst responsible for IP routing and carrier switching research. I've also done a fair amount of work around NFV and SD-WAN. So kind of have an idea of some of the things happening in the world of virtualization and with IP packet processing. So that's kind of what I'm going to zero in on and focus on today, is really the packet processing aspect of kind of what we're seeing in terms of development, and really try to not necessarily answer this question, are we plateaus? I don't think we are, but kind of give you an idea of some of the technological advancements, some of the changes we're seeing in the IP infrastructure and the technologies around routing. Just a little bit briefly, I know Dan mentioned the Dell'Oro Group and kind of our work as market researchers, and we've been around for, I think we're coming up on 25 years. I've been with the firm for about 20, almost 20 years coming up now. But I think just to kind of highlight, we are a really quantitative focused research group. We do this, our business model does a combination of financial and technology research. So it's kind of unique in that way, where we take a lot of quantified analysis, combine it with the technology, the innovations around networking, and present and provide that kind of information to our clients. Our client base is extremely broad. If you think about the ecosystem around telecom and networking infrastructure, we kind of go from the bottom to the top in that ecosystem, from component suppliers to the vendors, service providers, and really heavily into the financial community, where we work with a lot of the banks on Wall Street. This slide is just showing a list of what we do at Dell'Oro Group in terms of the areas that we conduct our research. When I started with the firm 20 years ago almost, there were two programs that we did, routing and switching. And you can see as over time we've been able to take this business and grow it to cover practically everything on the infrastructure side of things. We have a lot of great analysts who are addressing each of these categories. On to the meat of the presentation here. So the big question, has packet processing plateaued? Oh, that's a tongue twister there. But as I mentioned, I thought I'd do this from the perspective, a networking perspective, kind of taking the technologies that I'm familiar with, that I've been watching for a number of years. So kind of starting at the silicon layer, right? So the foundation of how packets are processed to transport and move across networks. From there, I talk a little bit about kind of that next layer in terms of the infrastructure, and that is the actual devices. In this case, I'm going to go with the core routers, the big iron, if you will, of backbone networks. This is where we see kind of the most traffic and most packets being pushed across the network. So kind of I guess the most advanced in terms of where we are in the capability of the systems. Are we running out? Is Moore's Law going to suddenly put a stop to all of this? So I'll talk a little bit about that and some of the innovations we see there, some of the historical perspective of what's happened in core routing. And then the last part, I'll talk about a little bit about the future, or the potential future, of where we see this core routing or this networking in the middle of the networks happening. I think earlier, Ofer from DriveNets talked a little about that, and I think some of our views there are fairly consistent with that concept of scaling out networks. And so I'll talk a little bit about that, but that's still kind of an open question. Really, there's not a definite time frame about some of the things I'm going to talk about in terms of going forward, but clearly I think you'll be able to see that it's not really something that's imminent in terms of plateauing in how we look at network and packet processing. So starting at the silicon layer, the last 5 years, this is kind of what this chart represents. We're starting on the left-hand side, not necessarily the chips specifically in each of these moving across, but really from an industry perspective, you go back 5, 6 years ago, the silicon was capable of processing packets in the hundreds of gigabits a second, 200, 240. But in the last 5 years, we've gone from that level of packet processing in the hundreds of gigabits now into the terabits. So we have silicon from the likes of Broadcom, Nokia, Juniper, in the terabits range. So we've seen a significant increase there just at the silicon level. So just from the pure packet processing capability that continues to innovate. Across the bottom is the silicon or technology node process numbers. Again, just kind of a representation of what we had 5 years ago to where we are today, from 40 nanometer technology process to 16 nanometer. So you can see from that, definitely getting smaller, but there's probably at least a couple more generations. And if you think about each generation potentially representing somewhere anywhere 3 to 5 years, so we're looking out probably at least 5 to 10 years before we start to run out of I guess, or the technology starts to become limited at the silicon level. Where we are today in terms of the silicon here, I think one notable thing on here is on the bottom right, the Broadcom silicon there. All the other chips shown here for core routing have been done as custom ASICs, designed and generated and produced by specific vendors, whereas the Broadcom silicon is merchant silicon, in other words, available to any manufacturer, anybody who wants to design or build a switch or router. What's unique about that is that historically, the silicon, the ASICs designed by the vendors have been tightly integrated with the software stack. What the Broadcom silicon has done is to kind of separate that so that the silicon is now independent, and vendors or anyone who wants to apply the software stack on that merchant silicon can do that. We're still kind of in the early stages of that in terms of that kind of integration being used in backbone networks. But I think if we go to the cloud providers, some of the largest there are starting to look at that and use that as part of their the model for building their backbones. So the next thing I want to talk about a little bit here on the next couple slides are kind of the evolution of what's happened in core routing, right? And so these are the big iron boxes that I noted earlier, used for internet backbones, for IP backbones, and also, and I'm not really going to kind of go too much in that direction, is used by the largest cloud providers for their wide area networks or their own backbones, right? So that's something that's I think probably, I mean, it's known, but probably not as well understood as to what happens in the cloud backbones. But I guess the way to think about it is that the largest cloud providers, and particularly here in the US, where we have Google, Facebook, Amazon, Microsoft, have all constructed backbone networks, IP backbone networks using core routers. We think about, we've heard from some of the other speakers how they have virtualized their data centers using white boxes for switching, interconnecting all their servers. That's absolutely true. But in their backbone networks, they continue to use vendor products. The integration of the software stack on top of the hardware, the ASICs and the line cards and the systems is still something that is in the realm of the vendors. So I mean, that's something to keep in mind. But that is also done, though, these backbone networks by the cloud providers has moved traffic off of the internet into their private backbones, right? So I think something that's interesting is that we hear a lot about traffic growth of video driven by video. Realistically, here in the US and in many parts of where these cloud providers also operate, they're carrying that traffic. It's not even hitting the internet for a large part of the where the video traffic is being moved. And so in effect, as we moved the cost of moving bits from telecom operator backbones to the cloud backbones, which are generally much more efficient. We've looked at some of the CapEx numbers globally, how carriers are spending, where they're spending on routing in their backbone networks. In the US is probably where we've seen the biggest decline, the biggest erosion of spending on backbone routing by telecom operators compared to, say, in Asia, particularly in China, or even in Europe to some extent. So it's an interesting dynamic where we see telecom operators not having to spend because the traffic is actually being consumed by the cloud providers. But that said, we've seen a lot of this migration over time. So as I think about what a router capacity, or how do you calculate or look at the routing capacity, right? So you have port speed, the interfaces on each of the that are available at any time, starting at 2.5 gig. If we go back to the late 90s, that was the highest capacity, OC48 ports on routers. And I remember I first started working in core routing and looking at the service routing, but that was a huge amount of capacity, right? So there was one 2.5 gig port on a line card with 8 slots in a system. So you had total bidirectional capacity of 20 gigabits, which was extremely large and seemed like the biggest thing in the world. I mean, that was a core router. That was heavy iron back then. As we migrate, or as we go through time, we've gone from 2.5 to 10 to 40, and now we're at 100 as kind of being the predominant high capacity line port. And then on the line cards, we've also seen an increase in density going from 1 port to 4 port, 8 port, 10, 16, and now we're even seeing up to 36 ports per line card for a router, pretty much limited by the physical space on the front of the line card. So it's not something that can really be changed, or you can't force more ports into that space. So that's kind of become kind of the highest level of density. And then you determine, or the final step of determining the capacity of a router is the size of the chassis. How many line cards can you put into a box to get the maximum capacity or throughput from a routing node, right? It goes from 8 slots to 16 slots. Then in the mid-2000s, we saw this concept of multi-chassis designs come out. And so that, in effect, linked multiple chassis together in order to come up with a higher capacity router. So when you kind of play with all these dynamics of what constitutes the capacity router, you kind of get this evolution. And I think one of the things, or there are many things about this that we've seen over time, but kind of going back to 1998. This is when Juniper Networks came out with their first core router at that time. I believe it was the M40. That was the 8 slot. 2.5 gig per slot, right? So that was the 40 gig was kind of what people refer to as Cisco math, doubling the numbers each direction, but it was really 20 gig bidirectional. And then over time, we went from standalone systems, the early 2000s, we got these multi-chassis systems in order to expand using 40 gig OC 768 at that time, or 40 gig. Was the kind of the highest capacity line rate there, and then moving on until we started to see 100 gig come out, maybe 7, 8 years ago on a limited basis. But today, that's pretty much the standard. But you can also see kind of how we've kind of gone from single box scaling to multi-chassis. But on the right, 2018. We're back to single chassis designs, and in fact, some of the chassis are even getting smaller. I think the other factor that has come into play is space. How much space do these routers take? You see that on the bottom row, that's the Huawei NE5000E, which is the system that's deployed in China at all 3 major carriers, right? So China Telecom, China Mobile, China Unicom, are all still using this multi-chassis design. It's pretty much the only place in the world where that design is still, or that multi-chassis design is being used, but they're up to 8 line card chassis with 2 control chassis or switch fabric chassis in the middle. 16 slots per chassis. I think 1.6 terabits per slot, line card. So you can see that you're now starting into the over 100 terabits in a system. But I imagine that it's quite power consumption heavy, and quite obviously space takes up a lot of space. But on the other hand, the distribution of population in China is such that where perhaps these designs make a lot more sense than you would see in typical place in, say, like Europe, or maybe smaller countries in Asia, or even across many of the different networks we have in the US. But today, on the right-hand side there, what we see is pretty much a very consistent approach of what the new routers look like, and will probably be along those lines for a number of years. Right? So these are going to be based around 100 gig. Most of them don't even go much below that, as opposed to some of these older designs that would have 1, 10, 100, 40, and be able to support multiple line rates. We're seeing kind of this jump forward to being focused purely on 100 gig, and starting maybe at the end of this year and into next year, we're going to start to see these products supporting 400 gig. So we still kind of have this room to grow in terms of going from 100 gig to 400 gig, to the point that, no, we're not getting close to plateauing, because also they think about how long these systems are being used. I think most operators in the telecom world and the service providers that are deploying these types of devices are doing it with the idea that a 5 to 10 year life of these products for these products. So even today, as investments are made, they're going to be really for a fairly long period. So, you know, we're not expecting that to really force the plateauing of capacity or the packet processing, because I think we've still got a lot of headroom there, as I talked about on the silicon side. A couple of generations there, we're going to 400 gig. There's really no plans at this point that I see to go to for 800 gig Ethernet, at least. That's probably way off in the future. So I think 400 gig is kind of going to be the sweet spot there of what we would expect to see in core routing. Now, one thing that is happening is that in the cloud operators, you know, they do have much more traffic that they need to deal with across their data centers. So, you know, I think, you know, it's still early days, but I'm pretty sure that they're looking at eventually replacing the core routers that they have today from an architecture or from a network architecture standpoint of having large boxes, to moving to more of a fabric design, where rather than putting in large boxes, starting to stack smaller boxes, or you know, boxes that are interconnected in a fabric or cloud architecture. Right? So you know, that's still early days. I think that that's something that we'll start to hear more about. I think that it's probably happening to some extent in some of the cloud providers today. But I think this is kind of the next step beyond. So I think, you know, while I mentioned earlier that, you know, we really expect that the current systems and current system designs of large chassis with 400 gig ports are going to be deployed, there will probably be a lot more consideration around this architecture. One, as perhaps an overlay or in a greenfield environment. We're seeing the idea and the growth of metro core networks expanding much more rapidly. So rather than just having, you know, one large core networking node or just a few large core networking nodes in metro areas, we're starting to see large routers being deployed more and more across metro networks because traffic is becoming more localized. I think that's an opportunity where we would see perhaps some of this type of architecture, because it, to some degree, will be somewhat of a greenfield. You don't have to displace or remove your old core routers. You kind of add in this new layer in the network. So, you know, these smaller boxes in this different type of mesh architecture, combined with all these SDN capabilities, and there's that term. I know that it can mean a lot of things, and in particular when it comes to routing, but really it's kind of the software separated, disaggregated from the hardware to some extent, the control plane, the management plane, all this ability to manage the traffic, manage the networks in a much more efficient way in very large capacity. So that's kind of what we expect to see over time. Again, we've talked about, I've heard some of the other speakers talk about today, the time it takes for operators to implement. I've often used the term telco time, and maybe the equivalent of dog years. But we've seen that. I mean, we've talked. We heard a number of comments around that today, and I think that will remain the case. But there's still always this opportunity for overlays and new things happening as the service providers really start to think about how they want to change their networks. And I guess it wouldn't be appropriate to do have a Dell'Oro Group presentation without some numbers in it, or at least a chart that shows some growth in capacity, ports, shipments, whatever. But this is kind of based around our routing forecast, 400 gig transition. You can see today that predominantly the market in terms of the high capacity interfaces are around 400 gig, but starting at the end of this year and into the next 5 years, the capacity that's going to be deployed will largely come from 400 gigabit Ethernet. So that's kind of our view of what we expect to see. So it's a very sharp growth, about 40% or more compounded annual growth rate over the next 5 years for total capacity. So there clearly is going to be an increase in volume, increase in shipments, and not anything close to plateauing in terms of how much we can expect with packet processing. So that's the end of my presentation, and I don't know if we have any questions. Yes, Ellen.
I have two. About 9 years ago, when I was the chair of IEEE Communications Society, we had speakers. We had speakers on 100 and 400 gig, and 400 gig was targeted at data center interconnect and internet exchanges, and maybe some others. With all the detective work that I've done, I have not found a single instance of 400 gig E being deployed, in particular by any of the large network providers or by the cloud providers, but then again, many of them are secretive. Do you have any comments on that?
Agree. Yes, from a service provider or telecom, I would agree. Zero in terms of 400 gig.
Okay.
So in the data center, starting in the fourth quarter of last year, we saw the first implementations of 400 gig switching in the data center. But it's not for interconnect or anything outside of the data center yet. Now, the cloud provider that is doing that is Google. So it's very possible that they are also doing 400 gig interconnect because they don't really use routing for that function, but clearly not using it in their backbone networks.
Thanks for mentioning Google, which is a segue into my next question. It seems to me there are 3 different market segments for routing, core routing, and routing switching. And they are as follows. 1, the cloud giants who do everything proprietary. They do their own high-level design, and then they farm it out to an ODM, usually in Taiwan, to do the detailed design. And Google and Amazon are definitely in that category. The second are those who are trying to adopt some open source hardware, some white boxes and part of their network, but still have the majority of their switch routers being sourced by traditional vendors. And those companies are AT&T and Facebook. And then the third is everybody else who is back to the old school and buying conventional switch routers from Cisco, Juniper, Huawei, Alcatel, now Nokia, and so forth. So given these 3 market segments, what do you see the outlook for each of the 3, and where are they now? Thank you.
Right. I agree that you could look at those 3 different or very different markets in terms of capacity, buying behavior or buying and the network design and architectures as well. So that's, in fact, that's internally at Dell'Oro Group, that's really how we look at these different markets.
Is the team that's trying to analyze it because a lot of the information is secret?
Oh yeah, we've got a lot of information. I mean, we can get down to, and we have matrices of for each of these cloud providers, what kind of technology, who the supplier, from the top of rack to the spine to data center interconnect to the core. I mean, that from the cloud providers, we have a pretty good view of that, what technologies they're deploying, so on and so forth. Similarly, we watch very closely what the telecom operators, you mentioned AT&T, while I agree to some extent that they are doing some things on their own, to a large extent they're still looking at, or they're still using existing vendors' products, albeit at deploying at a much slower rate. And of course, there is the rest of the world, as to, if you will, or the rest of the market. The interesting thing about that we see, and one thing around the cloud, is there has been a fairly significant trickle-down effect in terms of pricing, right? So maybe not necessarily in the technology of, as you mentioned, these proprietary approaches to networking, but for example, in the last year and a half, we've seen the pricing on 100 gigabit Ethernet ports on routers, these aren't switches and white boxes, but these are from vendors' products, decline at about 40 to 50% a year. There's been this huge pressure driven by the cloud, which then trickles down across the industry. So
Which makes the white boxes less attractive.
absolutely, and that was kind of the intent of the vendors to do this, was to kind of collapse a little bit of that premium, or a lot of that premium out of the market there, to essentially defend against the white box. That still doesn't address necessarily the software aspect of it, or the disaggregation, but it does kind of narrow that down. But in regards to your point about the rest of the market, do they do this white box, their own software, roll your own kind of thing in the network? It's less of an economic issue than as becomes perhaps operational. But in many of these cases, those operators aren't as big. They don't have huge backbone networks. I think it was Vishal mentioned the smaller operators around the country. I mean, they don't need these big backbone routers. But if they can get lower priced vendor products, and they can manage that, then that's fine. So yeah, so that's kind of how we look at it in the long run. From a forecast perspective, it does kind of create a very a negative pressure on the marketplace, because you have so much of it moving, so much of the market at the high end moving towards disaggregated solutions, particularly driven by the cloud, which then trickles down to telecom. So it really does create a pressure on the marketplace in terms of the market size, the available market. That's something different that we haven't seen before, which was where pricing was predominantly dictated by the vendors. Right?
Well, let me follow up.
Well, why don't we follow up at lunch, because it's time.
Yeah, absolutely. But thank you very much.
Thank you.